Hey guys, we are on 5.3. So 5.1 and 5.2, we were talking about exponents and the rules of exponents. Now we are talking about polynomials and polynomial functions. So poly just means many and nomial just means number. So we're talking about things that have exponents, terms, coefficients, constants, that have exponents, and we're going to figure out how to combine them, how to add them, how to subtract them, and how to multiply them today. All right, so polynomials and polynomial functions. I'm just going to write a polynomial here, okay? Let's do 6x squared minus 4x plus 9, okay? This is an example of a polynomial. It is also an example of a trinomial. Okay, like triangle or tricycle. Tri means 3. So because this has 3 different parts and we divide them right at those plus and minus signs, because this has 3 parts, we can call it a trinomial, or we can call it a polynomial. Poly just means more than one, okay? Many. So this is a trinomial. This is also a polynomial. Vocabulary, a term. So we have that same one. Yeah, we have 6x squared minus 4x plus 9. The term is the number, like 9, or the product of a number and a variable. The variables are letters in algebra, right? Letters that replace numbers. Product, multiplication, the multiplication of a number and a variable, like 4x, or a number and a variable raised to powers, 6x squared. So this polynomial has 3 terms. Okay, 6x squared, negative 4x, and 9 are the terms. This polynomial has 3 terms, okay? The plus tells you it's a positive number, so that minus means it's a negative. So always bring the sign with it, okay? So we have 6x squared, negative 4x, and 9 are the 3 terms of this polynomial. The coefficients are the numerical factors of a term. It sounds difficult, but just they're the numbers. So 6, 4, 6 and negative 4 are terms, or sorry, are coefficients. All right. I would not really call, okay. I would call 9 a constant. And a constant, yeah, the constant is a term that is only a number. So it's a coefficient because it's the number part of the term. So I would only say this is a coefficient and this is a coefficient. 9 is a constant, okay? The term that has only a number. Polynomial is a sum of terms involving variables raised to a whole number exponent. So the exponent will never be 1/2, 1/4, okay? And no variables appearing in any denominator, okay? So I'll just give you another one. 2x squared minus 7x plus 1 is another polynomial, okay? It's a sum, meaning we're adding together, but if we add together a negative, we're actually subtracting. So we're just summing up different terms. Monomial has 1 term, okay? So maybe 3x squared or negative x. Those are monomials. There's only 1 term, okay? A binomial will have 2 terms. only, okay? So if we had 2x squared plus 4x, that would be a binomial. There are two parts, two terms, okay? A trinomial is the examples we have already been seeing. There are three terms. Why is this so hard for me? Negative 2, 3, 4, 5, 6, 7, 8. Negative 8 x squared plus 13x minus 12. Okay, that would be a polynomial. Something else we need to talk about, or you need to know, is called the degree of the term. Okay, the degree of a term is the sum of the exponents in the term. Okay, so for example, the number 3x squared has a degree of 2. Okay. 5y squared z. This is a 2. This is an understood 1. So this would be a degree of 3. Okay. The number 7, degree of 0. Okay. So if it's just, and then degree of a polynomial, also important. Is the largest degree of its terms. The largest degree of its terms. Okay. Find the degree of each term. So let's practice. 5y to the third. This has a degree of 3. Right? This is a monomial with a degree of 3. Here we have x to the first, y to the first. So we have 1 plus 1 is 2. So this is a degree of 2. Okay. All constants have a degree of 0, just like the 7, degree of 0. So if we just have 8, no variables, the variables can't be raised to any degree. So we just say 0. And these were all monomials. Just like we said, trinomial is 3, binomial is 2, mon is 1, mono 1, monomial. Okay. So that was the degree of the terms because they were monomials. Now we have polynomial. Okay. Determine the degree of each polynomial and indicate whether the polynomial is a monomial, a binomial, or a trinomial. So remember, we said that the terms are divided where you see plus and minus. Okay. Those are my terms. Okay. So the number of terms tells me whether it's a monomial, binomial, or trinomial. Monomial has 1. Binomial has 2. Trinomial has 3. Okay. So if this is 3, this is a trinomial. This, even though there are 1, 2, 3, 4, right? There are 4 parts to this one. It is one term because none of it is separated by plus or minus. So this is a monomial. Y to the third plus 6y is a binomial, 2 parts, okay? And now we're going to count the degrees, okay? So this has x to the 5th. This has x to the 3rd, and this is 0, right? And remember, the polynomial, the degree is the largest degree of its terms, okay? So we add up all the degrees of the terms, and then whichever term has the largest degree, that is the degree of the polynomial. So 4x to the 5th has a degree of 5. 7x to the 3rd has a degree of 3. So we say a trinomial with a degree of the biggest term, or the largest degree. Sorry, that's confusing. The largest degree is the degree of the polynomial. So we say trinomial with a degree of 5. Monomial, let's count these up. So we have x1, y2, z1, right? So we have to add up 1 plus 2 plus 1 is 4. So we say monomial with a degree of 4. This binomial, y has a 3, this y has a 1. So this is a binomial with a degree of 3. Okay, or binomial to the 3rd degree. Example 3, determine the degree of the polynomial. So same thing. Let's separate them. Here, here, and here. Okay, and we'll add them up. That's a 1, that's a 1, that's a 1, that's a 3. So we have 2 and 1 is 3. 2 and 1 and 1 is 4. That's 0. And that's 3. Okay. Which one is the biggest? 4. Yeah. So this is a polynomial, because after trinomial, we don't really label them anymore. We just say polynomial. So this is a polynomial with a degree of 4. Okay. And remember, a trinomial is a polynomial, a binomial is a polynomial, and a monomial is a polynomial. Okay. So we can say this is a trinomial, or we can say this is a polynomial. It's like saying if you have a square, right? You could say this is a shape, or you could say it's a square. They're both true. One's just more specific, right? This is a polynomial. It is also a trinomial. All right. Find the following. Ooh, functions. Okay. It's p of x. So the way we say this is p of x. If p of x equals 3x squared minus 2x minus 5, find p of 1. P of 1. Okay, that means everywhere there's an x, and remember, p of x is the same as y. It's the same as saying y equals 3x squared minus 2x minus 5. So don't be concerned about that. It looks strange, but it just means it's a function. Okay. So what the 1 tells us is that instead of x, I want to put a 1. So instead of 3x squared, I want to say 3 times 1 squared. All right. So P of 1 is 3 times 1 squared minus 2 times 1 minus 5. Okay? 3 times 1 squared. 1 squared is 1. So 3 times 1 minus 2 times 1 is 2 minus 5. 3 times 1 is 3 minus 2 minus 5. 3 minus 2 is 1, right? Minus 5 is negative 4. All right, so our answer to this question is negative 4. The way we would write it, shouldn't have put a box around that, because the way we write it is P1 equals negative 4. Okay, same thing with P of 2. All right, so we have P of 2. P of negative 2 equals 3 negative 2 squared minus 2 negative 2 minus 5. Now we just solve that. Negative 2 squared is 4, because a negative times a negative becomes a positive. Negative 2 times negative 2 is positive 4 minus 5. 3 times 4 is 12 plus 4 minus 5. 12 plus 4 is 16. Minus 5 is 11. Okay, so we say P of negative 2 is 11. Now we are going back to terms, okay? Terms are, remember, when we put a number and a letter together, or a term could be just a number, or a term could be just a letter, okay? Like terms are terms that contain exactly the same variables raised to exactly the same powers, okay? It's the same as we're just simplifying. So we're not going to get, on the last page we got an, what do we get? We got a negative 4 and an 11, right? I double dotted. Simplifying. The last time we got 2 numbers. This time we're just going to get it as simple as we can. There's not really going to be numbers. So these 2 are the same terms. So we say negative 4 plus 2 is negative 2. The y stays the same. Okay. Z plus 5z3. Z plus 5z3. This one has a 3. This one has an understood 1, right? Those are not like terms. Can't do anything. You just leave it alone. Z plus 5z to the third stays z plus 5z to the third, okay? However, this x to the third also has an x to the third. So it's like saying 15 minus 1 is 14. X to the third stays the same, okay? 7a squared minus 5 minus 3a squared minus 7. Let's separate those. We have an a squared, and we have a constant, just the number. And it's very important that you take the negative with that number. So that's a positive 7a squared, negative 5, negative 3a squared, negative 7. And then we combine them. You want to put the bigger degree first. So we want to do the 7 and the negative 3 first. 7 minus 3 is 4a squared, right? And then negative 5 minus 7 is negative 12. All right. So those are our simplified polynomials. We simplified them as much as we could. We combined terms that were only exactly alike. Okay. To add polynomials, combine all like terms. Okay. Adding polynomials is just like combining like terms, which is just simplifying. So we have parentheses here, but there's nothing to combine. Those aren't like terms. Those don't contain like terms. There's nothing to distribute in front of it. There's no negative sign to distribute. There's no number to distribute. There's no variable to distribute, nothing. Okay, so we're just saying 3x minus 8x plus 4x squared minus 3x plus 3. You could even rewrite it if you want. 3x minus 8 plus 4x squared minus 3x plus 3, right? Those are the same. Now you want to find like terms. We have a 3x and a negative 3x. Interesting. We have a negative 8 and a positive 3, and then we just have that 4x squared. It's alone. It's the only one. So if we were to rewrite this, we would say 4x squared. Let's look at the purple ones. 3x minus 3x cancels itself out, right? Oh, but we could, here, I'll just rewrite it in order. Okay, so let's keep going. Plus 3x minus 3x, and then the red was minus 8 plus 3. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I haven't missed any. You're also welcome to like cross them out as you use them. 4x squared, cross that out. 3x, cross that out. Negative 3x, cross that out. Negative 8, cross that out. Positive 3, so that you know you use them all. Okay. And then we simplify this to 4x squared. Negative 8 plus 3 becomes negative 5, which is just minus 5. That is as simple as we can make it. 4x squared minus 5. We combined like terms. All right, add 8y to the third minus 4y squared plus 5, and is just a plus, right? 5y squared plus 1. So our like, you can rewrite it if you want, right? Our like terms are negative 4y squared, positive 5y squared, plus 5 plus 1. This does not have any like terms. So I would rewrite that as 8y to the third, 5y squared is a positive. If it has no sign in front of it, it's a positive, so you put a plus, minus 4y squared plus 5 plus 1. Okay, now we're going to combine them. So now we have 8y to the third plus y squared, because 5 minus 4 just leaves us with 1, plus 6. That's as simple as we can make it. All right, now we just go straight to like terms. X squared y. There is 1 here, and there is 1 here. Sorry, that's with the positive sign. Now we just have xy. xy, and we have y. And y. Okay, so those are our like terms. Like I said, I start with the biggest power. The biggest power is this one because it's 3, right? 3, 2, 1. So x squared y plus 10x squared y. This one's like it has a 1 in front of it, right? So we would say x squared y plus 10x squared y plus xy plus xy minus 2y minus y. And let's combine them now. So that's 1 plus 10, so that becomes 11. X squared y. 1 and 1 become 2. Negative 2 minus another 1 is negative 3y. And that is as simple as we can make it. So that is adding polynomials. And now let's practice subtracting. So I like to say that I am distributing the negative sign, okay? So I like to just put, like, even there's a 1 right here. And so I multiply 3x and 12x by a -1. That's how I like to think of it. But Pearson says add its opposite. So if you change both of these signs and add them here, okay? So if you change both of the signs, you have 7x minus 8. I'm going to change this sign. So instead of positive 3x, minus 3x. Instead of minus 12, sorry, negative 12, I'm going to put a positive 12. So I changed both of those signs. Or 7x minus 8. And then we're going to do -1. So the way I think of it is -1 times 3x becomes a -3x. And then a -1 times a -12 becomes a +12. So if you want to think of it as multiplying by a -1, or you just want to think of it as changing the sign, it's up to you, okay? And then you just follow the rules of addition. So we still have some like terms, 7x and -3x, and then -8 and 12. So 7 minus 3 is just 4x. -8 plus 12 is plus 4. 4x plus 4. Here, I'm going to change the sign of each one. So I have, first I'm going to write this one out. I think I'll fit it down here. Try. 2x to the third plus 8x squared minus 7x. Now I'm going to flip each sign. -3x squared plus 2x squared minus 3. Flipped each sign. Or I said this is a -1. -1 times +3 is -3. -1 times -2 is a +2. -1 times a +3 is -3. Whatever's easier for you to think about. So we have 2x to the third and -3x to the third. We have 8x squared and 2x squared, and then we have the final one. No, those are all the like terms. All right, so let's combine them. 2 minus 3 gives us a -x to the third. 8 plus 2 gives us 10x squared minus 7x minus 3. That's as simple as we can make it. Okay, and those are subtraction. Add or subtract as needed. Add or subtract as indicated. So 4 minus -y minus 4. I'm going to change both of these signs. 4 minus and a minus make a +y. Minus and a minus make a +4. So now I just have 4 plus y plus 4. That becomes, these are like terms, y plus 8. Like I said, I like the degree in front of the constant. Ooh, all right, let's rewrite this one. -a squared plus 1. Change the sign. So instead of a squared, we have a minus a squared. Instead of a -3, we have a +3 plus 5a squared minus 6a plus 7. Okay. These are alike. And then the +1, +3, and +7 are alike. All right. So we have -1 plus 1 is 2a squared. minus 6a. And then we have 1 and 3 and 7. 1 and 3 is 4. 4 plus 7 is 11. So I have negative 2a squared. I do not, guys. I forgot this guy. Negative 2a plus 5 is just a positive 3a. Did you catch that? Did you have the right answer written down and I had the wrong one? So I have a plus 3a squared minus 6a plus 11. So I'll rewrite it as 3a squared minus 6a plus 11. That's as much as I can simplify it. This one was y plus 8. And our last example, so it's adding, so we don't need to worry about changing it, right? We don't need to worry about, here we changed from positive to negative and from negative to positive because of that negative sign. But with the plus sign, we didn't change anything. We just said plus 5a minus 6a plus 7, okay? So we have 3x squared and negative 2x squared. We have a 8y squared and a y squared, and then we have a negative 7xy and a positive 9xy. 3 minus 2 just leaves us with x squared, okay? I guess it doesn't matter, we can go to this one. It's negative 7 plus 9, or you could think of it as 9 minus 7, right? That gives you 2xy. And then this one is 8 minus 1, positive 7. So we have x squared plus 2xy plus 7 squared. And that is as simple as we can get it. So this is just adding and subtracting terms of a polynomial. Anytime I try to switch to my webcam, I turn off my camera. Thank you guys for your time and attention, and have a great day. See you next time.